In our last lecture, we decided that we could summarize all of these networks with a /20 mask. But the problem with that was that we were not only advertising out that we knew about these routes, we were also advertising that we knew about the .10 and the .11 and the .13 all the way to .15. And that was a problem. So to remedy that, what we did was we decided what we would do is actually, instead of one summary address, we would actually create 3 summary routes, or one summary route, and then advertise the other 2 networks out with their default route. From here, from 0 to 7, we can advertise that out with a /21 mask, and that will encompass all of those networks in one route. And then, so we don't capture too many other networks, we decided the 8 and 9 would be advertised out individually, and we would just leave them separate. So this one would be one route, and this would be one route also. And we would advertise them out with their default mask of /24. So let's go into Packet Tracer and set this up and see where the potential problems can lie when you don't do it this way. So here's our Packet Tracer scenario, and what we want to do is summarize out the IP addresses that we've been discussing in the most efficient manner. And as you can see, what I've done is create a whole bunch of loopback addresses off of this router that represents the numbers we've been working with. And what I want to do is summarize those out to the rest of the network. We're using EIGRP, and we can summarize it as we've discussed with a /20 mask. But the problem with a /20 mask is that we're not only advertising out all of those networks, bravo, that works, we're also saying we know about the .10.0, .11.0, 12.0, 13.0, 14, and 15.0 networks. Well, we can see there's a problem there because we already have the .10 network down here. 192.168.10 network is right here, and here's .11. They are actually configured on our network. And so this router saying, I know how to get to them because of the summary mask, including those networks, could potentially cause a problem. We wouldn't want to do it. For that reason alone, we would not use that summary mask on this network. We wouldn't want to cause any conflicts. The other thing is, even if we didn't have those networks already configured, we would have just traffic possibly bouncing around our network, trying to get to the .15, the .14, whatever network it is, and they don't exist. So why have that traffic possibly on your network anyway? So we'll look at both of those. First thing we'll do is just look at why we summarize. And what I'll do is go into this router here, and we'll turn on router EIGRP. And what I'll do is just advertise out, or just enable, I should say, all of the 192 interfaces. Oh, and by the way, you can see that the do show. There they are right there. There's all those loopbacks I was telling you about. And so what I'll do is network 192.168.0.0 with a mask of 0.0.255.255. All that basically says is it must be 192, must have 168, and then I don't care any number. So then that activates all the interfaces with EIGRP. Fantastic. Do that, and if we go over to our other router over here, router 3, and we type show IP route, what we see are all of the routes it knows about. And look, it knows about all of those routes now. Well, that works. It's perfectly fine. But as you can see, the routing table is, getting bigger and bigger and bigger. And if routes drop, it has to go back out there and re-advertise that a route's missing. We can just take that information and eliminate some of the routes and just summarize them into one nice little block. And right from there to there, we can do that. So what we can do is come over here and go, hey, you know what? That's great. We turned it all on, all of those, but now we have to go under the interface to actually summarize. So we'll go under, I know it's that interface. So what you're doing here is advertising out this interface right here, SE0/0/00. So that's the one we're on. We come over here, we go into that interface, and we type IP summary EIGRP1, and we say 192.168.0.0 with a /20 mask. Let's see what happens. So a /20 mask would be, in dotted decimal format, 255.255.240.0. So 255.255.240.0, and we'll advertise that out. Now when we go and look at router 3 again, down here, here's what we saw just a few minutes ago, all those routes. Well, if we do a show IP route, look at that. We've taken all of those and summarized them down to a /20 mask. Great, it works. We have problems, we wouldn't do this anyway, but I want to show you why, even if we didn't have the 192.168.10 and 11 networks, we still probably wouldn't want to do this. If we go over to this client here, I'll switch over to simulation mode. I'll close out of this. If we go over to this client here, and this client for some reason tries to contact or communicate with a device on network, let's say 15, press enter. Well, because this router up here, this guy up here is saying, hey, with a /20 mask, I know about all those networks. And so, you know what? The packet will go to this router here. The router will look at this routing table and go, yeah, I know where it is. Set it up there. And this router goes, oh, the 15 network's right over here. And then shoots it to that router, and that router goes, you know what? There is no 15 network. Okay, go back. Let's do it again. Another packet goes out. And you can see this traffic is destined to nowhere because we don't have the 15. And so why advertise out that we know about the 15 when we don't know about the 15? And if we flip over to here and come out of simulation, that's what we get back. Destination host unreachable, because it is unreachable. But we have this traffic bouncing around anyway, possibly on our network, and we don't want it. So how do we solve that? Well, we solve it by going back over to this router here, and instead of advertising out a /20 mask, why don't we, and I'll just say a no here so we get rid of this one. So no to that one, up arrow again, and I'm going to advertise it out as a /21 mask. So we'll advertise it out as a /21 mask. And we'll go down here and enable that. Oh, got a 8 in there. Okay, there you go. And sure enough, everything comes up. If we go back over to router 3 now over here, and there was our /20 mask right there. I'll up arrow, do an IP. Look at this. Now we have networks 0 through 7 being advertised out by that summary mask. And then 8 and 9 are advertised out independently. We didn't have to do anything with them. Well, let's see what that does for our traffic situation. Let's go back over here. That's good. Let's open up our client again. We'll send out that same packet going out to 15, which we're no longer advertising that we know about 15 over here. So what happens, as it should, it gets to that router right there and dies. Nowhere else does that packet go out on our network. So we don't have all these packets bouncing around possibly on our network looking for networks that don't exist. We've taken the IP networks that we have and summarized it in the most efficient way we possibly could without conflicting with existing networks and without creating traffic to non-existing networks on our little packet tracer lab here. So that's route summarization in a nutshell, and you can see how it does make the routing tables much more efficient. Thank you for watching.